Okay, now we might have a situation where we have water flowing out of the cylinder and water flowing out of another cylinder, or water flowing out of the same cylinder with two different types of tube or two different lengths of tube. In any case, we might have more than one depth function. So we're going to let y1 equal the depth function we've already analyzed. We're going to let y2 equal this depth function. Now, we can pretty quickly sketch a graph of y2. The vertex is going to be at t equals 100. And the value at t equals 100 is going to be 200 minus 400 plus 300, going to be 200, okay? So I think the graph will look something like this. Now I'm doing this quickly, and I haven't figured this out in advance, but let's call that 100, and let's say we've got 150 here. So one axis of symmetry is here, one axis of symmetry is here. Initial depth of this one's 400, and it reaches its axis at 175, and so, you know, this graph will look something like this. This one starts at 300, and descends to a depth of 200. So the graph might look something like this. And I don't know, well, at 100, this is 200, so another big coincidence. This is just full of coincidences. This one just happens to reach this point as it hits its vertex. So this one has a vertex here and goes back up. This one has a vertex here and goes back up. But those parts of the function are not relevant. Okay, so anyhow, the question now is, what's the difference in the depths at which the velocities are both -2? Okay, now we get our v1 function, and that's going to be, you know, what we get here. That's going to be 0.02t minus 3, and v2 of t is going to be 0.04t minus 4. Now, these are linear functions. We haven't talked about linear functions with respect to this model, but let's just see what the graphs of these linear functions would look like. Now, both velocities are going to be negative because water's going down and because that's what the rule tells us here. V1 is going to have a y-intercept of -3. V2 is going to have a y-intercept of -4. And the x-intercept is going to occur, or the t-intercept is going to occur when y is 0. So we set this equal to 0 and solve. And we see that that's going to occur at 150 for the v1 function. So the v1 function has a graph that looks like this. And it's going to occur at, well, set this equal to 0 and solve, we get 100. And that's going to be this graph. Okay. Now, where are the velocities both -2? Well, I hope it's not here. But no, it's not going to happen there. So -2 is going to be like here. Okay. Well, this velocity is going to be -2 here. This one's going to be -2 here. So we're going to have some difference in the times at which these velocities are -2. You have to do an accurate graph. You can see how all this works out. So what we can find is, okay, V1 is -2, gives us the equation 0.02t minus 3 equals -2. And that's going to give us t equals 50. V2 equals -2. That's going to be 0.04t minus 4 equals 0, equals 2. And Now this is not gonna, this is, that's -2, of course. And this looks like it gives me t equals 50, but that can't be. So something is wrong here with my arithmetic or something, or with my thinking. Or I'm just really hitting a lot of strange numbers. Okay, so it would appear, okay, well, never mind. We do just happen to get the same depths, just as we just happen to have this one end at the point where this graph intersects this one. There was no reason that should have happened. That point really is the intersection, and it occurs at 50. So really, we have a point of intersection here when t equals 50. Okay, that's a little bit weird. Anyhow, had I chosen both velocities to be -1, you know, the -1 would occur like here, and we would have gotten a point on this graph, and a point on this graph, etc. I'll talk a little bit more about that linear graph maybe. But what we do now, okay, we just, you know, this is what we do, okay? We solve for V1 equals -2, solve V2 equals -2. We happen to get the same time, but you don't expect that to happen. So when t equals 50, what's y1 equal? And what's y2 equal? Okay, well, t equals 50, that's 2,500, that's going to give us 25 minus 150. It's going to give us 275. Plug t equals 50 into this. I think you get 275. Check my arithmetic. Plug 50 in here, and we get 2,500. That's going to be 50 minus 200, and this is going to be like 150. So the answer to our question, if these numbers are right, is that the difference in the depths is 275 minus 150 equals 125. Okay, and that is significant for the physics class. That will allow the physics class, for example, to determine in a certain situation the pressure loss between two different lengths of tube. But you don't need to know that. This is the mathematics behind it.